Alright, so we're going to take a quick look at moments. This is part one of about 3 different videos we're going to do. So moments themselves, the moment is a force and distance which help rotate a body upon a pivot point. So we have a pivot point here, we're going to apply force that's going to move this wrench clockwise. So in order to calculate it, we're going to look at force times distance gives us our moment. So the moment itself is equal to force times distance. So the force itself, perpendicular force to the wrench, times the distance from the pivot point to the force itself. And if you look back in week 1 or day 1 when we build those levers, we are calculating the force and the distance on those different levers and doing the calculations with the force sensors. So what do we got to look at? Units, Project Lead the Way, all caring about units. We've got foot and pounds, so we've got foot pounds, and then we have Newton meters working there. So making sure we keep the units consistent as we're trying to solve stuff. Quick reminder, clockwise and counterclockwise. Clocks are going away. A couple years from now, people won't know what that is, but we have clockwise direction and counterclockwise. Clockwise is negative, counterclockwise is positive to work with. So the first example we've got is the wrench. We got 20 pounds of force at 5 inches away, or 9 inches away. So we have 9 inches, which is 3/4 of a foot. So 20 times 9 gives us, going in the clockwise direction, negative 15 foot-pounds of pressure. The force times the distance. Change that to 1 foot, 20 pounds, increase the distance, increase the moment that is there. 20 pounds times 1 foot gives us negative 20 foot-pounds due to the clockwise direction. Now we're going to go and take this L wrench. We've got to go again and look at the distance, the perpendicular distance to that. We don't care about the 1 anymore. We care about that was 3 inches. Those 3 inches are the perpendicular distance that we're going to look and calculate with. So 3 is 1/4 of a foot, so 20 times the quarter gives us negative 5 foot-pounds due to that clockwise direction. So even though we got the same length of that wrench, the distance that we're using is only 3 inches compared to the 12 inches that were previously used. So that's why the moment decreases. Now we go and take the Z-shaped wrench. We've got to go over 8, up 9, go over 10. What is the total perpendicular distance? Perpendicular distance itself is 18 inches. 18 inches is 1.5 feet. Times that 20 pounds of force. Now we're looking at the negative 30 foot-pounds due to that clockwise type nature. So what do we want to look at? We want to look at equilibrium. We want the sum of all of the moments to be equal to 0. So therefore our structure as an equilibrium and balancing point for things. So there's 2 different things we're going to look at. We're going to look at the seesaw one. We're going to do that in the beginning of notes in class tomorrow. We're going to look at how those 2 bears can go ahead and level themselves out. We're going to look at the structure and the balance of this picture and this weights being on there, how much pressure in each one of those beams. We'll look at that in a separate video. And the other thing we're going to look at is then work our way to the trusses. We've got forces acting upon this truss. We want to figure out how much reaction force is being applied to those different structures there. And we'll do that in a separate video as well.